In 2002, the last Ford 7.3-liter Power Stroke rolled off the line. That engine had a B50 life rating of 350,000 miles. Mechanics across the country will tell you many of them blew past 500,000 miles without breaking a sweat. Cast iron block, cast iron heads, 6 head bolts per cylinder, a HEUI injection system, so overbuilt it was shared with International's medium-duty commercial trucks. 2 million of them were produced, and a staggering number are still running today. So what did Ford and Navistar replace it with? A smaller, lighter, more complicated engine that would go on to cost Ford over $1 billion in warranty repairs and recalls. That engine was the 6.0-liter Power Stroke, and what happened to the people who bought one is not a story about bad luck. It is a story about a corporation that saw failed durability testing before launch and approved the engine for production anyway. The first thing they buried inside the 6.0 was a ticking time bomb called the oil cooler. In the 7.3, the oiling system was straightforward and reliable. In the 6.0, Navistar designed a compact liquid-to-liquid oil cooler and tucked it deep into the engine valley, underneath the turbocharger, the intake manifold, the fuel filter housing, and the EGR valve. To reach it, a mechanic has to strip half the top end of the engine. The location was not the real problem. The real problem was what was inside the coolant passages. The factory engine block and cylinder heads were sand cast, and residual casting sand was left inside the cooling system from the factory. That sand, combined with suspended solids from Ford's factory coolant as it broke down over time, gradually clogged the tiny passages inside the oil cooler's heat exchanger. As those passages restricted, coolant flow dropped. Oil temperatures climbed past 230 degrees and kept rising. And because the 6.0 relies on high-pressure engine oil at up to 4,000 PS to fire its fuel injectors, overheated oil did not just mean wear. It meant degraded fuel delivery, damaged bearings, and an engine that was slowly cooking itself from the inside out. Every 6.0 with the original oil cooler was on borrowed time. The question was never if it would clog, it was when. But even if you caught the oil cooler before it killed the engine, there was a second failure waiting directly downstream. To meet Environmental Protection Agency emissions standards that the old 7.3-liter could not pass, the 6.0-liter was fitted with an exhaust gas recirculation system. The EGR cooler's job was to take a portion of the exhaust gas, cool it down, and recirculate it back into the intake to reduce nitrogen oxide emissions. The problem was that the coolant feeding the EGR cooler came directly from the oil cooler first. When the oil cooler clogged and starved the EGR cooler of coolant, the EGR cooler overheated. The internal welds on its core cracked. Once those welds failed, engine coolant poured through the crack and into the intake manifold and the exhaust system. White smoke billowed from the tailpipe. Coolant disappeared from the reservoir with no visible external leak. If the driver kept going, that coolant entered the combustion chambers where it did not compress like air. The result was blown head gaskets, or worse. Mechanics on the Power Stroke forums documented this cascade failure over and over again. Oil cooler clogs, EGR cooler cracks, coolant enters the cylinders. Head gaskets fail, and the real insult was that many shops only replaced the EGR cooler without ever addressing the oil cooler that caused it to fail, which meant the owner paid thousands of dollars only to have the exact same failure happen again within a year. Now here is where the engineering betrayal turns into something harder to forgive. The 6.0-liter held its heads down with torque to yield bolts, fasteners literally designed to stretch during installation. On paper, this was an accepted engineering practice. In reality, on an engine that ran EGR temperatures hot enough to warp metal and suffered chronic overheating from plugged coolers, those stretched bolts did not have the clamping force to keep the head gaskets sealed under pressure. When the gaskets let go, combustion gases forced their way into the cooling system, pressurized the coolant reservoir until it vented, and the engine lost its ability to cool itself entirely. A head gasket job on a 6.0 engine is not a weekend project. Most shops have to pull the cab off the truck to access the rear head bolts. Labor alone runs thousands of dollars. The total repair bill for head gaskets, studs, and the cooler replacements that should have been done at the same time regularly exceeded $7,000 to $8,000 on a truck that might have been worth $12,000. And sitting on top of all of this was the fragile fuel injection control module, the letters FICM, a computer that sent a 48-volt signal to fire the injectors. If the truck's batteries weakened or the alternator undercharged even briefly, the voltage drop could fry the FICM's internal circuitry. A damaged FICM meant misfires, hard starts, white smoke, and power loss. Replacement ran anywhere from $500 to over $1,000. Ford and Navistar knew about these problems. Pre-production endurance testing on the 6.0-liter Power Stroke returned poor results, and the engine was approved for production regardless. The class action lawsuit filed by owners in California said the engine was plagued by serious and pervasive design and manufacturing defects that rendered it unsuitable for use. In 2007, Ford sued Navistar, claiming the engine supplier had refused to share warranty costs. Ford said it had spent $1 billion on repairs and recalls. Navistar countersued for over $2 billion. The relationship between the two companies collapsed entirely. Navistar even halted shipments of the replacement 6.4-liter Power Stroke in a contract dispute, disrupting Ford's production line. The fallout was so severe that Ford designed its own diesel engine, the 6.7-liter Power Stroke, built in a Ford plant in Mexico, ending a supplier relationship with Navistar that had lasted since 1979. So what do you do if you are sitting on a 6.0 right now or thinking about buying one? The answer depends on how much truth you are willing to accept. The engine community calls the fix bulletproofing, and it means replacing the 4 or 5 components that were designed to fail. A quality oil cooler upgrade, an aftermarket EGR cooler built with stainless steel internals instead of the factory design, a RP head studs to replace the torque to yield bolts, a rebuilt or upgraded FICM, and a heavy-duty water pump to replace the factory unit with its plastic impeller. Done right, the parts alone run $1,500 to $3,000. With professional labor and a cab-off install, you are looking at $8,000 to $12,000. That is the price of fixing what should have been right from the factory. Meanwhile, clean 7.3-liter trucks with 200,000 miles on the clock are selling for more than some brand new half-tons. And the people buying them already know what most people are just now figuring out: the simpler the engine, the longer it runs. The fewer emission systems bolted to it, the fewer things there are to fail. Ford spent $1 billion learning that lesson. Do not spend your money learning it again. If you have a 6.0 story, drop it in the comments. We read every single one. If you want to know what happened when Ford tried to fix the problem with the 6.4 that replaced it, that story is even worse. We will cover it next.